Hey, everybody. Super glad that you are listening to this large language model in production roundtable. I want to mention before we jump into it that because of the success of this roundtable, we ended up organizing a full-on conference. It's a virtual conference. It will be held on April 13th, and you can register now. We're going to have incredible speakers like the founder of Human Loop, the creator of LangChain, just to name a few, and also the CTO of Adept AI. They just raised $250 million. Wow. All right. So if you want to register for that, check out the link in the description, and we will see you there on April 13th. I'm not going to chat for too long. I just want to talk real fast about the survey that we just put out in the MLOps community. This survey is kind of like playing off of what we're about to talk about. And I'm fascinated by like using large language models in production and how people are doing it, if they are doing it. And if you're not, why are you not? So please feel free to fill out that survey. It'll take like literally 5 minutes. It's the most basic thing ever. And that is my like one call to action that I have for everyone before we jump into this great conversation. I'm going to hand it over to Diego, man. I appreciate you running this. So we will talk soon. I'll be back in a bit.
Excited to have everybody here. A great subject, great amount of experts. So excited about the next hour. We're going to be chatting about large language models. So I figured we kind of start really quickly with a quick lightning round of introductions. Rebecca, we'll start with you.
Hi, everyone. Yeah, super excited to be here and kick off this discussion. I'm Rebecca. I'm a research engineer at Facebook AI Research. And so I work on primarily NLP, or focusing on the robustness of large language models. I also have worked on the fairness and responsible AI aspect of NLP as well.
Excellent. How about you, David?
Hey, good to see everybody. I'm a vice president at Unusual Ventures VC fund. I focus on our investments in ML, so I've been thinking a lot about language models and have spent before that like 6-ish years working on MLOps across a couple of startups, Tecton and Determined AI, and previously was at Ford where I did ML platform stuff like a lot of the folks I've talked to in the community. So,
Hannes?
Hi, my name is Hannes. I'm a machine learning engineer at Digits. I had the great chance to write machine learning related publications, one about natural language processing and then about MLOps. And we use large language models in production to assist accountants. So what Digits is doing is like basically a real-time engine to understand books for business owners and accountants in basically no time. And we use those language models to help start the conversation between accountants and the business owners. So we can talk about the details later.
Excellent. And James?
Hey everyone, really stoked to be here. I'm James, CEO and co-founder of Bountiful, and we're building a monitoring and testing tool for foundation model workflows. So one tool for FM app developers that allows them to actually observe and then test the cost, quality, and latency across their workflows.
Excellent. Great. And I'm Diego Oppenheimer. I'll be your opinionated moderator today. I'm currently serve as a partner at Factory HQ, which is a venture fund that specializes in AI investments. Previous to that, I was an executive running MLOps for a company called Data Robot. And previous to that, I was the CEO and founder of Algorithmia, which was one of the first MLOps companies. And I also was lucky enough to be part of this MLOps community since I believe there was double digits of people in the community. So it's been really, really exciting time to see all the hard work that Demetrios and Pelin, et cetera, and friends have put into this guy. Because what size are we at now, Demetrios? Because it's like cross 15,000, right?
Yeah, it's around 15K. It's wild.
Amazing. So really excited. So a lot of hype around ChatGPT and kind of what these large language models look like. And so I figured that we could start with grounding on like, what do we actually mean by a large language model? I'm going to pick on Rebecca on this one to kind of, define what's the proper definition of what we would look at as a large language model.
Sure, yeah. So this is a bit of a contrarian opinion, but I think this is actually really poorly defined. And this is just a new term for, what we can say is just transfer learning, which has actually existed for decades. But I can give people a bit of an overview. For those who aren't as familiar with the background and history of ML, so starting in the 1990s, this is when people started talking about machine learning and artificial intelligence. And this was a period of smaller statistical models. And gradually, so in 2010, we start seeing deep learning. So Jan LeCun coined this term. So we had larger data sets and more computation, and we see higher level features emerge through training on these data sets. And so really, this is a process of homogenization. So rather having bespoke feature engineering pipelines for each application, like you see that you could have the same neural network, well, deep neural network architecture, use it for a lot of different applications. And this process of homogenization has continued, and that's really what we see leading up to today, where we have really powerful large language models that can be used for a variety of applications. And so I'd say another inflection point was 2017, when we had the Transformers paper, like the attention is all you need paper. And then in 2018, we saw the BERT model. So then the years from 2018 until now, we saw so much like exponential growth and NLP, mostly happening on the research side, but now on the production side as well. So it's been a super exciting time for NLP. 2018 we had BERT, and then 2019 we had the Roberta paper, which showed that if you train with BERT architecture, but with like 10x data set, you actually can beat BERT on pretty much like all the tasks in the Blue benchmark. And then we just saw, this is like what showed that scaling matters and scaling is really powerful. And then we just saw this influx of, money and resources being poured towards training large language models. So we had BERT Large with 340 million parameters, GPT-2 with 1.5 billion parameters, T5 with 11 billion, GPT-3 with 175 billion, which I imagine a lot of people here are probably using for your apps. And now we have like really powerful AIs from OpenAI that we can use. And I would say that this is more of a succession of just us moving from very specific models for specific tasks to large pre-trained models that we can use for a variety of tasks. So yeah, I would say that this idea that's really central to foundation models or large language models is this idea of transfer learning, which is that, you can train a model on a lot of information and you can use it for a variety of downstream tasks. So instead of having like one model for sentiment classification and one model for question answering and one model for maybe like ranking your ads, you would just have one large pre-trained model that's very powerful, and you can just apply it with very minimal changes to a variety of downstream tasks.
Okay. So I guess to clarify a couple of things, we look at it as, large language models is a subset of foundational models, right? Because I think foundational models in general would actually apply to not just language models, but also kind of like image, multimodal, whatever's coming out. There's some characteristics to these large language foundational models. I think in general, we can call them that they're no code in terms of like we access them via natural language, which really expands the ability for people to use them, right? I mean, I think that's really what's one of the biggest things that's inspiring. The second, kind of what you mentioned, Rebecca, they're kind of, they're no tasks, right? So they're actually pretty general. They're not task specific, and they generalize quite well. And I guess we're still figuring out to what other tasks they generalize on a daily basis. And I think one thing that I know of, that which is I think also really interesting, is that they don't really suffer from a traditional ML cold start problem, right? Which is like you can actually start working with them without any sort of like pre-trained data. So one thing, and I know you said you had a contrarian view, but like one of the things that had been like thrown out there is like, what do we consider large? And it feels like some people say like, okay, like the billion parameter kind of like, line is the, what we'll draw it. It felt kind of arbitrary. I mean, it sounds like a nice little round number, but, do you have any comment on that?
Yeah. So I think this is also super interesting. I'm sure people have seen the llama models coming from Facebook, but now we're actually seeing that maybe you can do more with smaller models, but just train it on more data. So for anyone who's curious, you can look up the Chinchilla paper. So there's this idea that models have to be Chinchilla optimal, which means that if you have like a 1 billion parameter model, you have to train on X amount of data. But then if you increase the number of parameters, you have to train on maybe like 10x or 1000x more data for it to be Chinchilla optimal. So really, it's not just about the parameter size. It's also about the amount of data that it was trained on. Because a lot of, I'd say the first generation of these large language models were undertrained. And that's what researchers are realizing right now.
Got it. Awesome. Great. So we have these, access to these really large models, and I think there's I think it's kind of funny because we went from, very, very specific like task models, tons of training data. Hey, we're going to go do this, and this. And now to the more generalized models to now like really or say, well, actually what we really want to do is kind of like the generalized models, but also combine them with smaller models. And I think a lot of the reasons why combining them smaller models is really around, okay, these things are actually really hard to put into production. They cost a fortune. And the kind of like economics are slightly flipped, right? I think like anybody who's, so I've spent almost a decade looking at just production problems. And as soon as we kind of looked at these like LLMs, I was like, I don't like how, where, like how we're going to make businesses out of it. But cool thing is here is that Hannes has actually spent quite a bit of time doing some of that work of like, okay, how do we actually make decisions? Do we use APIs? Do we use our own models? Do we continually pre-train our own models? So I'd like to give you the floor and kind of talk to us about like your use case, whatever you're willing to share, but also kind of like what the thought process was, right? And how you broke down getting to, a specific in production use case here.
Yeah. So there's like, we use large language models in a variety of cases. Like we have this case of like regenerating some text for some users. We use large language models to define very custom embeddings. And I think to me that is the beauty right now. Like 5 years ago, we said like data is the new oil. With the large language models, because there's so much work already they're pre-trained, it's more important to have clean and good small data sets so we can train that custom use cases. So it's not like the quantity of the data anymore where we can bring them into production. I think Rebecca made a really good point. You need a lot of like data to train it to get to your initial stage. But once you start reusing them, then you can fine-tune this with a lot of with smaller data sets. So that the number one would be like there's a good motivation to use those language models because we can get to a production-ready model with smaller sample sets. I remember like back in the day, like 2015 and so on, we were working on a similarity model where we didn't have large language models, and we spent a lot of time like curating the data just to get to initial state. The other thing is like when we talk about like large language models in terms of like generating text, we need to think about like how do we integrate this into the product. So for example, we need to protect the users against hallucinations or against like weird generated text. And so what we do on the digit side, when we generate a text, it goes through a very stringent, not safe for work filter. If it's like the slightest rating there, we throw this sample away. And then we check constantly against patterns of hallucinations. And if it follows into one of those patterns, we also throw the sample. And then we make sure in our app, whatever we show is like reviewed by an accountant before they actually send it to their client. And then that is another layer of like, there's a human in the loop who could say, this makes sense or doesn't make sense. But at the same time, those large language models allow to integrate amazing applications. So for example, we're helping business owners to understand their books in real time, but accounting is highly subjective. So we use large language models to understand the subjectivity with large language models. And then we train like similarity-based machine learning models, or we use those generated from AI.
Some of the decisions you made previous to starting to work with these models. So I think like it really, really what I'd love to understand a little bit better is like you have the option of using potentially an API. You have the option of grabbing some of these open source models that exist today. Maybe actually, is it worth like for the panel actually like talking about what exists in the open source community. Because I think a lot of people are unaware that there's a huge movement that is, it's not just OpenAI building, these models or actually like big cloud providers, but there's actually quite a big community of researchers who have built open source large language models like Luther and a couple others. So I'll actually let any of the panelists want to kind of like take that one and, because it sounds like you've all looked at it. So I don't know if I got any volunteers here.
No, pipe up.
Yeah, there you go.
Spent a lot of time kind of in the open source communities. I mean, number one, it's unbelievable some of the capabilities that kind of communities of people are turning out. I think I'm going to actually message in the chat a few key Discord servers that I think literally just jumping into summarize some of the best work if you want to go and understand the open source pushes. And so, yeah, you got Alethea AI, you got Carper AI, who are championing some of the attempts to kind of build open source alternatives to some of the largest models. Lion as well, doing really interesting work. I think, look, I'm not a developer, so I'd love kind of alongside me, Hannes or anyone else, to kind of give a developer's viewpoint on this. For sure, when talking to companies who are building at the application layer, right? I think they start, at least in our experience, they start building on top of APIs, and then they start to consider, okay, there's this sea of open source equivalent models that I could be using that might give me some advantage based on what I really care about for my users. Let me start investigating this, right? And a great place to start is literally jumping into those 3 Discord servers to understand what's being done. And obviously Hugging Face as well as kind of a lineup of what models exist and what could be used.
Great. So one of the things to talk about, and then I'll pass this on to Hannes, right? So these models are available for download, which are great. I mean, they're not as easy as accessing them as like, hitting an API. And in a lot of cases, you're going to have to do some inline pre-training or some fine-tuning yourself to actually make them usable. But they're portable, right? And they're not relying on just being behind an API. And so when you have a lot of use cases that are potentially not good for just using somebody else's API and sending data, these are definitely options. So you're not kind of boxed out of using LLMs because of it. So with that preamble, Hannes, love to walk us through the thought process here of, and you don't have to give up obviously any secrets, but would love to understand like considerations, how you thought about the problem, like what were those qualifications, and then kind of like we can walk into like how you did it.
Yeah, there's no secrets. I would say like we actually, in fact, we published a blog post about like how we implemented it. So if somebody wants to repro this, go ahead and conquer. So when we saw this business problem of like generating questions, for example, obviously people go to the OpenAI playground, they try it out, and you see like, okay, is it actually feasible with a few prompts? And then the first step was like, can we actually repro those things with an off-the-shelf model which we could host in-house? Because the thinking there is like, if that is possible, then we have the opportunity to quantize and prune the model to reduce the latency. And we have this major benefit of not handing over the data to an external API, which we're not in control over anymore. And so for us, with CQD and financial data, this is really paramount to everything we do. We promise our customers that we're trying to, we're keeping everything secure and in-house. So even going to OpenAI is that burden is tremendous and would change even if we have a ramification of the terms and conditions with our customers. And therefore there's a huge motivation to can we use open source models and host them ourselves? There's another benefit of you have lower network latencies if you have the model sitting right next to you and your instance. There's lots of cool benefits. But to what Diego was saying, you do have to fine tune the model. But in that moment, you also have lots of opportunities to make those models smaller, make them domain specific, make them useful to your specific use case, and the model can then in the moment forget about all the other use cases in the stream.
So speaking of use cases, and you kind of mentioned one where very particular needed to be able to kind of bring it in house. David, you've been looking at a bunch of things. You've been looking at the developer ecosystem. David also wrote a pretty cool blog post about the developer ecosystem. But what use cases are you seeing, and kind of how to maybe kind of talk a little bit about how to think about when to use, let's focus on production, right? And production use cases and what, when to go in one direction, when to go in the other direction, what you're seeing, that's really interesting right now.
Yeah, I guess like I have a framework that I used to think about this, which is like, okay, so we just talked about foundation models and they've been coming for a while, but like this capability kind of got dropped in our lap magically by OpenAI a couple years ago. And so like when you think about what's being used in production now, I think a lot of how to think about it is just like, how much time have we had to execute with this amazing new technology we have? And so I frame everything through like, how long does it actually take to build it? And so the obvious stuff that you saw in production first, I think, is like the most simple application of language models. And it's stuff like Jasper and Copy AI that are completing text, right? Or in the like sales category, like Reggie and Autobound, folks that are kind of like generating sales copy and sales emails and things like that. And so why? It's the easiest thing. Like the production is like basically just a call to OpenAI. You add one API call to your application and you're good. And you can do really incredible things. And so a lot of the stuff that requires no infrastructure, you see really successful in prod right away. And then you get like one layer down, like what's the next level of complexity as you try to do things? I think like the most obvious stuff is, okay, we want to incorporate external information about the world or about our users into these models. Sort of like what Hannes was just talking about in one sense, like you need to understand what's going on in the world to be able to do anything in accounting or documents or spreadsheets or whatever it may be. And so there you have to start like building infrastructure, databases, integrations, pulling data from whatever sources you need. And there's just like the fundamental time it takes to do engineering. And so I think we're in the moment right now where a lot of what we're seeing come to production are tools where people have finally finished that engineering workload that it takes to like make all that happen. And it even could be some amounts of fine tuning and things like that. But for the most part, I think it's like just like browsing stuff from a database, connect to Slack or whatever. And so like in that category, like there's stuff like ChatGPT, it requires a little bit of context of like a whole conversation and wrangling that, or all of the bespoke chatbots that got announced when they announced their new API last week. A couple of folks that I've worked with, like Mem, which is a competitor to Notion, reads your historical documents and emails and stuff like that to help like complete, do text completion, but more personalized to you. Working with a company that's in our portfolio called AppEdge, who do this awesome like customer service work where they have to connect to like Jira tickets and Zendesk tickets and Slack to like know what's going on. So I guess that's like my tier 2 of complexity. And for the most part, people like in that tier still aren't doing the amazing work that Hans has done to like actually go grab a model, fine tune it. Like that's hard work still. And this stuff is like kind of somewhat straightforward, even if it's more complicated. So I think of like, what's the next tier of complexity? And I think there's like 2 big categories you can get to. One is like increasing model complexity. So like big chains of calls where you have like want to do agents and you want to call it to a language model and get a response and parse the response and call it to the language model again. And that just kind of gets unwieldy still. Like we just haven't really done it's just actually like kind of hard to be confident in the systems you build with that in a way where you're like ready to put in front of users. I don't think a lot of people have gotten there yet. So there's like these open source frameworks like LangChain and stuff out there where a lot of people are doing cool stuff by making chains, but trusting that, I think this is probably why James exists, is because like trusting some of that back and forth with a model is still challenging. And I think this is another engineering gap where I think it's just going to take us time as a community and as a set of developers to figure out like, how do you do it? And how do you manage it in a way you can trust? And the other side is stuff like automation, where you're like, like a lot of stuff you see now is Copilot. Hannes talked about this, where you have a human in the loop to validate. And that's because like the same thing, it's like hard to build all of the tools we need to trust models right now. But where we want to go is automation, where we have LLMs doing everything. But that again requires just a ton of engineering work. And going down that route, like that's where people really think fine tuning is necessary. You kind of have, or RLHF, like the more complicated methods of owning and tuning models that you can trust. I talk about like, there's a big difference when you give the LLM the keys to the car versus the autopilot. There's a lot more things that can happen. And so I guess like long answer, but I think there's just a what we're seeing is more and more engineering complexity getting layered on to this amazing ML thing, and use cases spawn up nearly daily because of the amazing progress we're getting. But you can sort of track it on a straight line of how complex people are willing to go. And I think the next frontier to what Hans was talking about is, okay, can we yell in weights? Can we distill models? Can we do lower latency work? Because there's that's a ton of engineering complexity. Some people are bold and on the frontier doing it. But I think a lot of people are still sort of in level one.
David, you bring up a really good point that every open source language model comes with its own tokenizer, as an example, right? Like you have your bird that has like work piece tokenization. You have your LLM that has like sentence, and even like fitting those pieces together, that is a whole challenge. And I totally glanced over this. Like, I'm sorry about this, but like once you get over this hump and you actually have the models and the weights in front of you, then you can run, like, for example, the TensorFlow profiler and like see what can I cut out of this language model and make the latency fast. And this is something which maybe you don't have to do for the problem, but if you see a lot of inferences, that investment might pay off. And then you're sort of discoupled C from the API, you get a faster response and you save money long term. But to your point, there's lots of engineering complexity in there. So it's like, I can see the trade-off for like stars. It might be easier to code an API because you get it up and running faster and versus long-term benefits.
One of the interesting things is, Diego mentioned up front that like a lot of what's happened is this like democratization where so many people can develop with language models. And so it's like, oh, I just go write a prompt and I've done something cool. And man, it's really intimidating, just like it always has been, to go from that to like, I'm going to download weights and learn TensorFlow and tune a model and use the TensorFlow profiler. Like I was an ML engineer for a whole bunch of years and I never used the profiler because like getting to that level is kind of scary still, And I was like, I think a decent one, maybe. And it's still like, there's like depths of ML problems. Like it gets really complicated really fast. And so I think there's a lot of people sort of on the sideline once you get to that level of complexity, because it suddenly like, it's like, we've told everybody you don't need to learn ML to do ML. And then it's like, oh, never mind. Just go fine tune a 13 billion parameter model. Good luck. And I think there's still a ton of work we have to do to make that as accessible as a prompt, maybe.
I was just going to double tap on that. Like a bunch of we've talked to many dozens of generative AI companies, right? And most of them are not, the people building these companies are not ML developers. They're not ML engineers, right? They're not ML people. They are software engineers that are trying to build really interesting software by kind of plugging in these incredible pieces of technology, right? And they're playing in the tier 2 complexity, David, that you just explained, right? Whereby, okay, we're going beyond tier 1, which is kind of, you might describe as that kind of UI wrapper style, like demo of like, this is cool, I can build on this. But to actually building kind of semi-agentic chained systems, right? That get highly complex very quickly. But even jumping to that third tier where it's kind of do-it-yourself ML development, I think is just a huge barrier. So I think we're going to see very large companies built in that tier 2 of complexity, right? So we saw like Jasper, enormous company, right? Built on that tier 1. I think we're going to see a second wave of a huge number of companies that we're observing right now building that tier 2 complexity. So we're building the tooling that enables people to actually manage that complexity such that they can build really interesting agentic systems and then potentially automated ones. And then I think who knows when we get to like tier 3, right? And like Hannes has done very non-trivial work as an ML developer and ML engineer to get to that stage. I think in that 2-tier complexity, we're seeing a lot of highly capitalized companies that are just building that tier 2 as software application players. So that's why we're building what we're building, is to try to enable them. But I think we're going to see a huge population of those companies.
So I'm going to try to completely oversimplify kind of like what kind of 3 categories that we can talk about for LLMs in production. I want to talk about trust. And in trust, we'll talk about trusting the results, security, privacy, anything that's regarding kind of like, the ability to use these. let's talk about latency. And I'm making latency a category because I think it's completely underappreciated how much latency matters in building any sort of software. Maybe to your point, James, about how all these software engineers are actually working on these problems, it might be more present. But, we'll talk about, kind of latency, and then we'll talk about cost, right? And so I think those three things. And I think in all of these three things, I think we can break it down into the engineering tools that are going to exist, how we're actually going to apply them, what people are doing, what research is coming in, because I think new architectures are coming out. And so we can start on any one of them, right? So I'm going to define cost as literally what it costs to run. And this isn't just about, the API call, we're talking about what it takes to rent all the hardware, what it takes to, lift up that hardware, what it takes to kind of run that at scale, as well as potentially use the APIs, obviously. I mentioned a little bit about that trust, right? So trust, we'll talk about privacy, security, the use cases there. And then, now I'm forgetting the other one was latency. Latency, which is really the definition of the use cases, right? So maybe we'll start with latency to begin with. And, James, I know this is near and dear to your heart. So
Yeah.
first of all, define to us what latency is in these kind of LLM world use cases. How we should look at it. And more importantly, maybe kind of touch on some of the problems. I think it's an unsolved problem, by the way. So I don't expect you to answer it for us, but kind of we can, if you want to kind of frame it for us.
Yeah, absolutely. So I think you can observe and think about latency at two levels, right? One is at the kind of instance level, specific model. And then one is at the workflow level, right? From a more kind of user perspective. Because you're trying to deliver ultimately some kind of user experience that adds value to someone such that you can build an application, potentially build a company, etc. So when you're calling, let's say you're at that tier 2 of complexity that David described, right? You've got a chained kind of workflow of potentially multiple instances of models. It's going to give you an idea here. I was talking to a founder yesterday and he got lost walking me through his own kind of workflow here. And he's calling 7 different instances of models, right? 4 of them fine-tuned Babbage. There are a couple of embeddings models in there, right? And each of those calls, based on the API, is bringing in some sort of latency. Chained together at the workflow kind of level, you have the ultimate latency that the user experiences. And I think that's going to be king, right? Especially in the second level of complexity. It's I need to build, especially for those who are building here, thinking software, right? And to your point, Dio, you said maybe they're thinking more about this than others. They absolutely are. So we've talked about when in our conversations with companies is a cost, quality, and latency triangle, right? And depending on your use case, you care about one of those more than the other two. And the best example of this is Code Copilot, right? GitHub Copilot, latency is everything. You have to stay within a flow state for your user experience, such that they could make those functionalities better, but they don't want to because they want to maintain a very, very low latency. That's how I think we need to start thinking about this. There's a latency of making one call to one model, but then there's a latency of an end-to-end user experience.
Yeah, I love how you picked that example because I've many times used that example as the kind of state of the art in terms of latency, and it's pretty darn slow, right? In terms of when I look at right now, it's a suggestion, but I want autocomplete, and jumping from suggestion to actual, doing autocomplete will require fairly significant engineering to be able to get that. And actually, my guess, and I'm not the expert here, is that it will take kind of re-architecting some of these models, or from the ground up. So I don't know. I know we have a question here that people are asking about production. I'm going to quickly define production, and then I'm going to jump to you, Rebecca, because I saw you get excited about re-architectures. So what we mean about production is actually an actual application that's being used for users, and I would argue kind of in a kind of in a production matter. So a service that is being offered to other people, that is running all the time. This is beyond the demo. This is beyond the, kind of toy weekend, kind of thing. This is you're actually using it as part of a business process, education process, whatever you're using. Production is, I usually like to define it people scream if it goes down. And so I think somebody was asking about, like, does that count the Open API service in Azure? Absolutely. If you're using it as part of a production application, like if you're just using it for your GUI app at, on your computer, then I wouldn't consider that production. So rewinding a little bit, we'll go back to, what is it going to take? We're still on the subject of latency, and, state of the art right now is a couple milliseconds. I think actually, like, there was a paper that talked about state of the art in kind of like what I call in a lab environment was a 29 millisecond inference pass, which is like, discontinues a bunch of use cases that I've been traditionally worked on in ML, which are kind of like sub 15 millisecond use cases. But back to you, Rebecca, what are we seeing that's going to be able to like hit this latency problem?
Yeah, no, that's a great question. A lot of thoughts on this. Yeah, I think Hannah's the optimizations you mentioned with like quantization and model distillation. Awesome. Yeah, there's a lot of great engineering work happening now. So I actually think that engineering, especially infra engineering, infra knowledge is really relevant. So yes, it's people need to learn, PyTorch TensorFlow, learn how to fine-tune models, but I think actually more and more just hard engineering skills are increasingly relevant to NLP and just to the productionization of AI going forward. So yeah, just really want to drive that point home as well. You need good engineers in this space. On the inference side, so some of the inference being slow is indeed, Diego, I think you hit the nail on the head here. It's the transformers architecture. So transformers is great for long-range dependencies and capturing context, and it's actually faster in training because you have access to all of the input, but it's not good for fast inference. And, this is something that is very inherent to the architecture, and that's why people are talking about latency and like inference speed so much, because like we are bottlenecked just by the transformers structure. And so if you compare transformers to models for like recurrent neural networks like RNNs, transformers are not naturally sequential. So RNN decoding is going to be a lot faster than transformers, which have your multi-headed attention matrix computations. So you just have more computations, and added to that, we also, we're talking about LLMs, so there's also just more parameters in these models. So in every forward pass, you have a lot more layers, tensors to get through. So it's just, I think just everything just compounds to being slow, right? So yeah, I think some of this will require, if we really want to talk, like just like removing this bottleneck entirely as opposed to like working around transformers, which is what we've been doing, it will probably require an architecture change. That's going to be hard because we've seen transformers have been so dominant since 2017, and it looks like it's becoming more and more dominant and not going the other way around. If people are interested, and this is still very much in academic research territory, but something I've been excited about is something called state space models, which is sequential. And so that they've underperformed compared to like transformers models so far, but they're I think that takes off. Watch out for that coming out of Stanford. Then we can solve the.
I'll put the paper in the chat, the Hungry Hippos chat.
I just want to jump in there because Diego, you said in passing, right? It basically invalidates right now a whole host of use cases. Like that fundamental latency barrier. Like there are so many things that you can do in principle that currently you can't do in practice because of that fundamental latency barrier. Even if, especially when you're at that tier 2 complexity, right? Like so the founder I was talking about that I was building this company, initial pass on that workflow was 15 seconds, right? Now that is a fundamental like end-to-end user journey that just doesn't work. It's a non-starter, right? Like everyone's like giggling a little bit, right? Now he managed to get that down to like 3.5 seconds through kind of fine-tuning Babbage instances rather than using large models, etc., taking this tier 2 complexity perspective. And it might be good enough. That might be good enough to build a really interesting company on top of in that tier 2 complexity. But that won't cut it for other use cases where 3.5 seconds just kind of lasts you out of the room, right?
And there's plenty of like orders of magnitude of like for each person with a 7 calls to an API, there's someone with 70 in mind or thinking of 700 to do complicated things. And so like it's hard to describe how many orders of magnitude room there is for improvement. It's a lot.
And I think like we're talking about LLMs in production, right? We're talking more broadly about foundational models. You consider kind of multimodal world that's coming down the pipeline, right? Which is just going to be fascinating. Maybe that's an unhelpful grenade to throw into the room with kind of 15 minutes to go, or maybe it's a helpful grenade. Who knows? We'll find out. But I think one thing I wanted to get people's opinion on was like taking the Moore's law approach of these large models, right? If we assume that some of these very large models are going to go just get cheaper and cheaper and cheaper and get faster and faster and faster, like what changes fundamentally over the next 12 months? If, okay, we don't know why, but like maybe it's a new fundamental architecture, but in 12 months, OpenAI has a model that is just 10x faster and it's 10x cheaper again. Like, how does the world change? I'd love to hear kind of instincts on that.
I think we potentially have like a divergence, right? Where you actually don't get, you don't get actually the, one like larger model, mega model that it just gets smaller and cheaper, but we actually get back to highly specialized models. Or, I think I've actually seen implemented recently, and it's really interesting, these kind of like start with one of these very large language models and actually use them as a router, like a task router, into a much more specialized task. And I see Hannes is like nodding. I'm guessing that's what he's doing internally, which is kind of starting from a more generalized task, right? Because you take advantage of the kind of like no need for the pre-training, kind of like no cold start problem. You can like go into a use case and then route from there into something a lot more specialized. That accumulates latency though, right? And so I think like going back to kind of like, because I want to like close down the thought on the latency thing. Like I think, the most important part that I see here is like, you really need to go down to the use case and say, okay, what is this use case requirement, right? For a latency? Because, if I'm looking at near real time use cases, like the reality is that at least today, right, I'm kind of out of luck, right? Like, and so you're not really going to be able to achieve those. You're going to have to look at different architectures, smaller models, distill it down to like very specialized to get anything even close to that. And if you start thinking about, again, like, you look at things like you've mentioned, like, chaining these things, you're just accumulating latency, right? And, across those chains. So you get into, and again, if you have a big batch process, it doesn't really matter. But I think that's, that's really interesting, because I think we're, and I don't want to be like too deterministic here. We live in a probabilistic world, but like, I think right now, truly real-time use cases are kind of out of the question in like point today in time, at least from, kind of like production perspective, at least from what we've seen. Now, that said, I'm sure that the Facebooks and Googles and, kind of like Microsofts are very much working on this problem, but I think that's a reality, at least in its current state. Anybody disagree with that, or is that kind of can we get happy?
I don't disagree, but I just think it's bold to be recorded making claims about where we are.
I said point in time.
Yeah. 2 months, and we'll be like, do you remember when latency was a problem?
Yeah.
But I think latency is a function of like the business case, the way we deploy, like. For most of the applications we're talking about, we don't need a general model like ChatGPT, right? Like we can go to like a domain-specific application. And what worked really well for us was like sort of like the teacher-student approach, where we take a larger model and then break this down into something smaller, cut out layers, and then so if I compare like the latency from our first BERT deployment a couple of years ago to like what we have now, it's like magnitude sticker. It is like, and we were able to get like reduced models. We would get the profilers, we get XLA, we get all these optimizations. And so now we can even run those models on the CPU in a very condensed version. And then the costs play a role as well, right? Like you can throw money at it. And as somebody has said in the chat, like you could just use a GPU, right? So if your business case pays for this, that's an option. But I think to make it very domain specific is the biggest latency saver you can go after.
Yeah, I think there's a comment on the chat. I think like let's talk about. I think I'll rephrase it. Like we're talking about latency across the entire workflow, right? Which also includes like everything else, right? Like the system you're building likely has overhead The problem is that you're actually significantly adding a bunch of latency, while usually in like any of these kind of like online systems, or offline system, the latency your system's adding, everything from IO to database pulls to everything. Like you're now adding significant amount more as you kind of like chain through these to these models. So I love it. You gave me the perfect segue, Hannes, here. It's like talk about, and you might be able to kind of put it on CPUs. And anybody who's worked in this space knows that that is the holy grail for your wallet, given that running GPUs is about 4x what you can do on CPUs. And so I'll go back to, and I'm definitely stealing this, James. I love the triangle of the quality, cost, and latency. And so, determining the use cases, right? Because when you look at inference on GPUs, and you look at that, they're on average, and I think it can be on average, it's about 4x more expensive. That's what really you need to be like talking about. So let's talk about cost and the use cases, around that, and how to think about. I'm going to pick on you, David, because you're probably looking at a bunch of companies and being like, yeah, this sounds great, but if they scale, like they can't afford it to actually like, run this company, at any like cost, like that makes sense. Even though, GPT 3.5 is now 10x cheaper. Or actually, I'll just let you answer.
It's funny. Like, I think this is an interesting question because it's really important. Like, and I've seen what happens at scale, and it's almost like worth handing to Rebecca, because like meta scale cost becomes pay for whole departments by making 1% improvements on like their ad ranking engine, right? Like it's insane what happens at scale with inference. For startups, like when you're getting started, I just like, I don't know, light money on fire, like beat people, win, and I just haven't seen it be a constraint early on. It's certainly, you have to do the math. So like, it's really easy to back of the envelope. How much does one inference cost? How many inferences will you do? What's your margin per inference? And you can figure all that math out. Like you can get there on the APIs in particular. Pricing's all pretty easy to predict. And so I always do that math. It's good to do that math. It's good to know where your margin's at. But, I think part of how I think about it is thanks to folks like Hannes who've gone down the road before and shown us that you can build domain-specific models and there is room to optimize. Like, it's a question of figuring out when to optimize for cost is for most of the people that I work with. And for most people, it's not day one. For Meta, it's certainly true that you have to do it, and it's worth hiring 100 engineers to work on it, maybe, or a lot, because it's so important. But it's just this thing that you evolve with over time, monitor. I always recommend people be aware of, but I haven't seen it block a lot of use cases early on. That said, I know a lot of people that were really happy when the new chat API came out, was 10 times cheaper, because, this is like, for startups, at least, you're talking about runway, like how much money do you have in the bank to survive is changing, and that's critical. But I don't know, you can do it. Like, I think you can hire an ML person, you can learn ML, you can fine tune models, you can, like, I think there are tools out there to avert cost, which is something you have to be thoughtful of more than anything.
Is this an exercise, Hannes, that you did up front? Like, did you think about, even back of the envelope, like, okay, we're going to go do X, Y, Z, this is what it's going to cost? Like, you talked to people in your team that were beyond the ML team, because I'm assuming this is like, at least involve product management or leadership of the company in terms of like, yeah, we're going down this route.
Absolutely. We went back of the envelope calculations. It's a little bit tricky with OpenAI, like how many tokens does it actually require to solve this task, right? We did some back of the envelope estimations, went to the CEO, was like, would you be okay if this data goes to another API? There's all these like privacy questions there. And then there's obviously a cost question. And for the tasks we had implemented, it was more beneficial to do this in-house. Just to give in like a little bit of insights on the scale, though, we have to process close to 100 million transactions a day. That is not like something we could easily ship over to an API. And then we have to talk about like latencies, etc. And in that moment, even the project of like investigating the model and figuring out what can be cut so we can actually run it on a CPU fast enough was super beneficial. So then we can talk about like what happens if we run this as a batch process with streaming, that sort of stuff. But yeah, it costs is basically the first question we need to answer the whole entire project.
So we're gonna go into the last subject of the morning here. I guess morning for us, evening for James, which is kind of trust in these systems. And so there's one term that I think it's worth defining, which is like, and some people might have heard of it, that these models hallucinate. And I'm pretty sure that's not because they're just trained on a bunch of people's Burning Man pictures. Maybe, Rebecca, you can actually kind of like help define what a hallucination is in this context, and why, we'll kind of discuss why this needs to happen.
I would say hallucinations, just anything that's not factually accurate and just falls into the accuracy problem when you're thinking about evaluating language model outputs. Sometimes it's open-ended, like how engaging or interesting are these outputs? Sometimes it's like, is this fluent? Are there grammatical mistakes? But what a lot of people are caring about when we're productizing these is, I don't want the model to say that, Michelle Obama is the president, for example. That's like embarrassing for my brand, embarrassing for our company. And this is a problem that has actually existed in language models for years, but I think it's become a bigger problem because now people are actually using these LLMs for real world tasks. So now, it's not just like researchers writing papers about hallucinations, how to improve it. It's like actual, users of these LLMs saying, oh, my model just, wrote this text for this downstream use case, like maybe like generating legal text, for example, and it's just totally wrong and really embarrassing for a company. So yeah, I think that this is, we talked a little bit about research directions. I think David maybe, or Hades has mentioned, having basically external knowledge sources, plugging in like retrieval, right? I don't think he said retrieval, but like I think we're describing it as like retrieval augmented generation. So yeah, large language models currently as it stands, I think they're very poor sources of facts and knowledge. And this is because it's just not very parameter efficient to be learning facts. And so I think the way forward really is having these knowledge bases and combining it maybe with like a retrieval component.
And actually, I see in the chat, Venkat actually hit it really well, because this is how I like to describe it. I mean, like, we're used to very deterministic workflows and code, and we've been building deterministic systems for a really long time, but now we're applying kind of like a probabilistic, kind of like implementation to some of those. So maybe some of the tips and tricks, and maybe not tricks really, but like how have people been thinking about making these things feel more deterministic? And there's been a lot of techniques that have been used by different teams, to do it. But I'd love anybody jump in here in terms of how to think about some of in production, some of the techniques you can use to make these workflows feel more deterministic. I think you talked about kind of like the teacher-student kind of model. That there's like kind of the human reinforcement kind of model. There's a bunch of these different models that can be used, not to confuse with the actual models, in terms of how to do it. So I'll open up the room to anybody who wants to kind of like touch on that, because I think this is so important for us to build trust in these systems, right? And truly adopt them in most people don't understand what a probabilistic workflow is. By nature, humans are bad at it.
I think you got to start the use case again, right? There are some use cases right now that have like high affordability of something not quite being right? Such that I can generate an output, and there's affordance for my users, such that, okay, if it gets a slightly wrong or very wrong or whatever, hey, that's fine. I won't churn the user, and the user won't take a bad action on the back of it. There are obviously low affordance use cases that we just can't serve today, right? Like, I don't want a medical diagnosis for an LLM, right? Because that's very low affordance, right? If it gets it wrong, it's game over, right? So, and I think, I wonder how long it will take until we start to slide down that affordance scale. That's kind of as an aside to your question, but I think it's good context.
LLMs have this really cool approach. So like, they're basically databases with a constant lookup. And so because we have to compute the weights, there's just a fixed number of weights, but as a downside is like we lose out the accuracy of the results being returned, right? And so what I found really interesting was like, okay, there's ChatGPT, there's some submission risk in there. And then when I saw the implementation, what Bing is doing is basically like they used like generate me a query. That query goes to a database that gives you the top 5 results, and then it goes back into a summarization application. So in that, but in the benefit here is like it leaves out on the constant lookup, but the benefit is you basically get all the references whenever it states something. And maybe in the meantime, we need to think about on a system level in such a way that like, okay, how can we trace back references or things like this? And for the moment, give up the constant lookup concept and then work towards that. That maybe is part of the model as well.
Fantastic. We are at the hour here, so I want to be respectful of everybody's time. First of all, I want to thank all of you, David, Hannes, James, Rebecca. This was awesome. This was really, really fun conversation. I think, like told Demetrios, we should make a conference out of this. This sounds like there's so much to talk about, such an exciting space. I totally agree with what James said. Probably eat crow on anything I said today in 2 months from now, just based on, like the speed at which is moving, everything's moving. And that's the fun part. So I always reserve the right to be wrong constantly. So with that, I will pass this on to Demetrios. Thanks for having us.
Yes, dude, this was so good. We're going to do a conference. I'm already planning it. The last thing I'll say, if you haven't put your information into this survey, I'm going to release it to everyone. So I'm dropping it in the chat right now. Again, throw in if you're using these large language models in production, or if you're not, we want to hear why. And then I will reach out to you with the answers and all the data on this. I think there's already been some incredible answers that have come through. I love it. And I also will try and make some kind of like TLDR report on it so that everybody can see what we're all doing and where we're all at with this. I thought this conversation was perfect. So thank you, everyone. And I may be giving out some of these bad things happen to good data shirts for some people that fill out this this survey. So bad things happen to good data. We know that. And if you drop in your email in the survey, you could win one of these shirts. All right, everybody. That's it for today. See y'all.
Great chat. Thanks, everyone.
Thank you.